So thank you very much for Tribeca for offering the opportunity for us to share our very exciting journey where we are revolutionizing the recovery of critical minerals, and we're starting with battery recycling. So to understand Iondrive, it's best to start with, we've got a strategic partnership agreement with the University of Adelaide, with their chemical engineering department, which is the #1 chemical engineering department in Australia and ranked number 40 in the world. They've got 170 researchers actively doing research on battery materials, battery recycling, critical minerals, and led by 2 laureate professors, which is very unusual for a department to have 2 laureate professors. So that arrangement, that agreement gives us exclusive rights to all of the IP that is developed by the university. So one can view them as this massive IP engine that sits behind a lean and mean commercialization team that are taking these technologies to market. So the university does the fundamental research, and that allows us as a team to develop that technology further, to make it workable at scale with our engineering experience and project experience, but also everything that we do in parallel is market and development. So we're very conscious of the fact that, often tech companies design solutions looking for a problem. We're very conscious of that, and we do exactly the opposite. We work with the market first to understand what the problems are, and then we feed that back to the university to do the fundamentals, the solutions that we then scale up. Right, so that's Iondrive. To illustrate that, the commercialization aspect of us that we're very strong on, this slide has got 2 aspects that are significant. The first one illustrates our business model. So if we look at the battery recycling industry here, represented by this value circle, for those who are not quite familiar with how battery recycling works, the batteries at end of life are then collected. They shredded into what's called black mass, and we take up a midstream position where we take the black mass, extract those critical minerals from the black mass, and then as our first priority, our second priority is to then convert that into PCAM material, which is the precursor cathode active material that goes to CAM manufacturing and to the battery cells manufacturing. The second significance of this slide is that Iondrive has been invited to a consortium of industry partners representing this entire value circle in Germany that was set up by the University of Aachen, which is the smaller version of Fraunhofer Institute. Now, Fraunhofer Institute is world-renowned for setting up industry clusters to resolve industry problems. The Fraunhofer model is one where you always involve academia, industry, and not government. So government will typically co-fund the activities, that academia will provide the IP, and then industry will do the execution. So this battery recycling cluster was set up to initiate a battery recycling industry for the whole of Europe. It is a pan-European approach, so the Netherlands is working closely with Germany. Belgium is soon to follow. And it's a real feather in the cap for a small Australian company to get an invitation to participate in this industry consortium and taking 2 main seats as main industry partner. So the technology that we're developing is super sexy. It's called deep epitectic solvents. We can talk about deep epitectic solvents for an hour and a day, but please visit us at booth number 28 where we can explain how it works. But in our case, with cobalt and nickel, which is prominent in MCN batteries, if you remember from the periodic table during your chemistry days, cobalt and nickel sit right next to each other. And they literally join by the hip. If you want to separate them, they follow each other through any process, conventional hydrometallurgical process. So you then need downstream processing to separate them. The deep epitectic solvents is specifically tuned with a formulation that will first dissolve selectively the cobalt, leaves the nickel in a solid state, And then in the next process, the nickel is leached out of the solid material. Now, the other thing about the deeply tectic solvents is we can have the university do that formulation for deeply tectic solvents for any target metal that we want to leach out from a mixture of metals. So, for example, we've got a program with the university to look at e-waste recovery. We want to recover the gold, the valuable precious metals like gold, platinum, palladium, etc. Now, how our process is different from traditional processes is, firstly, you've got pyrometallurgical processes, which is hundreds of years old, where you literally just burn everything away and you're left with your metals as an alloy that then needs that further separation downstream. It's very energy intensive, and then secondly, it also destroys all of the lithium. Conventional or traditional hydrometallurgical process typically use very strong mineral acids like sulfuric acid, that's toxic, and it's a reagent, so whatever you put into your process then comes out of the process in mass as a waste product. So again, in the case of sulfuric acid, you produce sodium sulfate, which is a real problem in Europe. It's an unwanted product there. So the downsides of hydrometallurgical processes also high in energy, but massive waste problems and requires a lot of water to treat that waste. Our process, which is a solver-metallurgical process with a deep eutectic solvents and other benign organic, in fact, all of them are biodegradable solvents, are used in a closed-loop process. So you'll use a specific solvent mixture to selectively leach a target metal from that mixture in a closed-loop process. So as soon as the solvent is leached out, it gets recovered and recycled, and the solids move to the next process where again it is not segregated and recycled. So the net effect of that is that it uses less energy, but also an orders of magnitude less waste that you've got to deal with. So it really is a clean tech process. And we've done extensive benchmarking on what the costing of a large-scale process will be, and we were very surprised, pleasantly surprised, to see that our capex is 36% cheaper than a conventional hydromet process and slightly cheaper on OPEX. So for the next 3 to 9 months, where we are in commercializing this technology for the battery recycling, is end of November, we did a capital raise to fund a pilot plant project, fully funded to have the pilot plant up and running by the end of the year. And some of the other activities are shown here. And again, just highlighting the fact that everything that we do is technology development in parallel with commercial development. So the top row shows some of the commercial activities that we engaged with through this year. It's strengthening those industry partners that we've established in Europe, so broadening that consortium to multiple countries, and then also penetrating the US market in parallel to what we're doing in Europe. And then the technology development things in the bottom row is getting this pilot plant up and running, but then also extending our technology to adjacent industries like the e-waste that I've already mentioned, and then also MHT, which is metal hydroxide precipitate. Earlier there was a discussion on Indonesia, so typically that's the nickel product that Indonesia exports to China, and that offers the opportunity to valorize that as an intermediate product to our battery-grade materials and PCAM. So our large-scale plant that we have designed and costed, we've also put it through extensive economic modeling. So all of the factors that you see here have been independently verified. So for example, the metals pricing that we used here, provided by Terry, wherever he's in the audience, from Benchmark Minerals Intelligence. The modeling was done by Model Answer, an independent company in Perth, and the engineering work and CapEx and OpEx estimations were done by the Wood Group in Perth. So it shows an NPV of almost 250 million at a discount rate of 10, a healthy IRR at 17.4%. And it's worth mentioning here that it is a very conservative approach in both CapEx and OpEx. So it's really an internal stress test for us to understand how profitable and how affordable a project of this nature is. But we believe that there's much upside in reducing CapEx and OpEx costs. So we often get the question from investors, so what is in it for us to invest in Iondrive at this stage that is building a pilot plant? So we've compiled this graph here with comparison companies. The bottom row, we've got 3 companies, Ascend Elements, Scilab, and Decycle. They've got a number of common denominators with us. The first one is that they're also, all 3 of them, spin-outs from universities. The second thing to understand here, which is the real interesting thing, is if we look at their investments on the primary y-axis, so on the left, the vertical bars that represent that in blue, compared with their market valuation on the secondary y-axis, the axis on the right, illustrated in green. The important point here is that as soon as all of these companies have successfully demonstrated their technology at pilot plant scale level, their market valuation, which is the second bar on the right for each of them, their market valuation increases by 10x or 10 bagger. So, investors that want to invest, and we're not here to ask for anything because we are fully funded, so it's kind of weird doing this presentation to this audience and not asking for anything. But that is the answer to investors. If you want to invest now, you can expect a much bigger valuation on successful completion of the pilot plant. And then just at the top there, we've got some comparable companies, our peers on the ASX, MTM and IPX, just showing what their valuation is at different stages in commercialization. Just a little bit about Iondrive and the capital structure. Like I said, we are an ASX-listed company. We've got a market cap of about 25 million. We've got 2 cornerstone investors, Strata Investments and Terra Capital. So the CEO of Strata Investment is also chairman of our board. And then for the last capital raise, we brought 2 institutional investors, Terra Capital and Regal, on board. And the bottom right there is just our share price. It had a really terrific capital raise end of November, where we had 100%, double what we asked for, that we trimmed down, but at a 17% premium, which is really unusual for a microcap company on the ASX. And the share price has since come down a bit, and this week with Trumponomics has not been good. And then, the real key to success of commercialization is the strength of your team. So we're very blessed with a very competent and a very complementary board. And in fact, it's also a real pleasure that 3 out of the 5 board members are actually here in the auditorium. So just underlining their enthusiasm for what we're doing. And then also joining me on the bottom right, there's Lewis, our commercial director. So just a bit of market context. This is really important to understand why it is that we're focusing on battery recycling, and specifically Europe, which is the second biggest market over and above China. So what's illustrated here is that black mass that we process, more than 75% of that worldwide is exported to China where it's processed. So Europe and the US have got real aspirations for that sovereign manufacturing capability in electrification. And China's been really smart at sewing up the supply chain of these critical minerals. So the only way that Europe and the US can get access to these critical minerals is in the recycled batteries. So I'm just going to skip over this. This is our commercialization plan, having that pilot plant operable by the end of the year, then a demo plant before 2030, and then a commercial plant by 2032. And the significance of this is that we're perfectly in sync for when these end-of-life batteries start hitting the markets in real numbers with our commercial scale plant. And I've run out of time here, but I just want to leave the audience with a few key concepts, because it has been a bit of a mouthful. We've got a massive market opportunity here that we want to exploit. we've got a really, really interesting and competitive nut and technology that is revolutionary, and it can be extended to adjacent industries like the e-waste market that we've spoken about. And then thirdly, a plan is only as good as the people that are executed. And we are blessed with a sensational team that are very well experienced in commercializing technologies and taking microcaps like us to much larger organizations. Thank you.